Okay, so let's look at our base function here. All right, what is our base function? Well, our base function is 3 to the x, right? 3 to the x. And this is what our base function looks like on the graph. This is what our base function looks like on the graph, right? Now, let's look at what different shifts do to the graph. Let's look at what different shifts do to the graph, all right? So suppose we have a shift of -4 here. What does that do? Well, let's look at the x-intercept. Let's look at the y-intercept, where this function crosses the y-axis, all right? What does that -4 do to it? Well, first, the y-intercept was at 1, and now, after -4, well, it's at -3. So you see a shift down. By 4. All right, let's do the opposite. Let's have 3x, and then we will go +4. Well, our y-intercept used to be 1, but now it's 5. So with +4, you see a shift upwards. Of 4. All right. So then let's see what other shifts do to the graph. All right. Suppose we had a shift. Suppose we had a negative sign here. All right. What does that do to the graph? Well, you saw it used to be above the x-axis. Now it's below the x-axis. So it's a flip over the x-axis. Whatever used to be up here, so this used to be 0, 1, and now it's 0, -1. And every subsequent point has been flipped. So adding a negative sign out here makes it flip across the x-axis. All right, now let's see how we can stretch this function. All right, let's see how we can stretch this function. All right, so suppose we had a 2 here. Let's see what that does. So we originally have this, and now we have 2. All right, so let's see what this function is at 1. At 1, this function is 3. At 1, this function is 3. All right. Let's see if we put our 2 out in front. What is it at 1? At 1, this function would be 6. So you see, it's stretched it by 2. The value is twice what it can be. And it's a vertical stretch. We're stretching it up and down. It's going up, it's going further up. It's a vertical stretch, all right? So suppose let's put some of our transformations together, all right? Suppose I put a negative out here. What do you think is going to happen? Well, it's going to stretch by 2 first, and then it's going to flip across the x-axis. Suppose I put a +4. Well, what's going to happen? Well, first it's going to stretch by 2. Then it's going to flip across the x-axis. Then it's going to shift upwards by 4. So you see how we can combine all of these different flips and different transformations of the function together. All right. Now, finally, let's see what adding or subtracting from the exponent here does. So suppose we add a +1 here. A +1 in the exponent. In the exponent, we add a 3x plus... Okay, why aren't you letting me do this? 3x plus... Oh no, it's not letting me do that. 3x plus 1. Will it let me? Will it not let me? 3x plus 1. No, it won't let me. Okay, that's all right. We can look at what it would... Suppose this is the x-axis, and this is the y-axis. All right, x-axis, y-axis. And we had our equation 3 to the x plus 1. Y equals 3 to the x plus 1. All right, if we put in x equals 0, what would our y equal? Well, let's figure that out. Well, y would equal to 3 to the 0 plus 1. So 3 to the 1 is y equals just 3. All right, what if we had x equals 1? Well, y is equal to 3 to the 1 plus 1. Well, 1 plus 1 is 2, so 3 squared is 9. 3 squared is 9. So y equals 9. Y equals 9. All right? So let's graph this. All right? So when we had x equals 0 here, y equals what? Y equals 3. Y equals 3. When we had x equals 1, y equals 9. So 1, 2, 3, 4, 5, 6, 7, 8, and then it goes a little bit above here. It goes to 9, and almost 9. Oh. Okay, let's redraw this line. Okay, this is probably better. All right, so when we have x equals 1, x equals 0, y equals 3. When we have x equals 1, y equals 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, right? Y equals 9. So how does our graph look? Well, oopsie. Our graph looks something like that, right? And it keeps going up. All right? Let's compare that to our y is equal to 3x. Y is equal to 3x. So if x equals 0 here, y equals 3 to the 0. Well, anything to the 0 is equal to 1. So y equals 1. Well, what if we had x equals 1? Well, that would be equal to y is equal to 3 to the 1. Well, that's just 3. So we know y equals 3. All right, so when we had, with our original function here, let's do this in a different color. Let's do this in blue. All right, with our original function, when x equals 0, y equals 1. And when x equals 1, y equals 3. So 1, 1, 2, 3. All right. What about when x equals 2? So let's do x equals 2. Well, y is equal to 3 squared, which is 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So y equals 9. So how does our graph look here? Our graph looks like this. All right? So you see, with our shift of 3x plus 1, we see our graph was shifted to the left. So 3x plus 1, 3x plus 1, this white line, our graph was shifted to the left of our original function. So our original function was y. Our original function was y to the 3x. Our original function was y to the 3x. And that is this That is this function right here. That was our original function. And what does this shift here do? What does this adding this plus 1 here, what does that do? Well, if you see, that's this line here. So basically, it takes every point on this graph, and it moves it left. It moves it left by 1. So here you can see, when was y 9? Well, it happened when x is 2. Well, when was y 9 on this graph? Well, it happened when x is 1. So you see, adding 1 in the exponent shifts it left. Right? What if we were to subtract 1 from the exponent? So let's subtract 1 from the exponent. So let's go y is equal to 3x minus 1. All right, y is equal to 3x minus 1. Well, all right, let's plug in x is equal to 0. So y is equal to 3, 0 minus 1. So y is equal to 3 to the negative 1. That's equal to 1/3. 1/3. Let's plug in x is equal to 1 now. Y is equal to 3, 1 minus 1 is equal to 3 to the 0, which is equal to 1. All right, now let's plug in x is equal to 2. So y is equal to 3, 2 minus 1, which is equal to 3 to the 1, which is equal to just 3. Okay? So when x is equal to 0, y is equal to 1/3, which is approximately this. When x is equal to 1, y is equal to 1. Yes, you got it. When x is equal to 2, y is equal to 3. Oh, whoops. 3. Okay. And let's do another one just for fun. Let's plug in x is equal to 3. So 3 minus 1 is equal to 3 squared is equal to 9. So when x is equal to 3, y is equal to 9. X is equal to 3, y is equal to 9. So you see here, when we subtract 1 in the exponent, we're subtracting 1. So we're subtracting 1 in the exponent. What happens? The equation shifts right. Rightward. Okay? The equation shifts rightward. Okay? So this is our base function. This blue function is our base function. When we add 1 in the exponent, it shifts left. And when we subtract 1 in the exponent, it shifts right. So hopefully that makes a little bit of sense. All right, so let's go over. So when we have an exponential function, some number z to the x, right? So it could be 2 to the x, all right? 2 to the x, let's take that as an example. When we add to 2 to the x, it shifts upward. When we subtract, so when we add to the to something, when we add something to an exponential function, shift up. When we subtract something from an exponential function, it shifts down. All right, when we put a negative sign in front of an exponential function, it flips across x-axis. Okay? When we multiply something by a exponential function, it gives us a vertical shift. A vertical stretch. So here in this, when we're adding and subtracting, we have a vertical shift. But with this, we have a vertical stretch. When we're multiplying it by something, we have a vertical stretch. And then when we add to the exponent, we shift left. And when we subtract from the exponent, we shift right. All right, so these are our shifts with our exponential function. So hopefully that clears things up.